All right, let's get started. And given the topic, again, I suspect Ben is possibly the person who's likely to know something about it. So why don't we start with Ben and work down as usual?
Well, this is where I'd be like, yeah, I definitely know what I'm talking about. I know Tarun. I can't say. I don't know how to pronounce his name. One of the main authors, or at least I've followed him on Twitter for a while. So this is. I think this is a very interesting concept. Let me try to describe what I think is going on here. So the way a zero knowledge proof works is you have this. You have a prover and a verifier, and if I remember who is who, one of them, I think, believe the prover has the knowledge that you're trying to prove you have access to without giving away, and the verifier is trying to verify the prover knows what he says he does, without, of course, transferring the knowledge directly. So the whole point of a zero knowledge proof is the verifier walks away with the knowledge that the prover knows the fact but did not reveal the fact. So you can always think of the knowledge as some kind of like string of 32 byte string or whatever, a random key or something. It could be anything. The important point is that the prover does not give the verifier the string, but the prover is able to prove to the verifier that it knows the string through some mathematical way of doing it. And the way you do it is through this challenge response thing, where basically, because this is not some arbitrary piece of data, unless you have a perfect zero knowledge proof. It's some piece of data, like maybe you have a private key for a public key. So the verifier does know something about the problem. Like in Zcash, the verifier knows the rules that the transaction is supposed to have. There's supposed to be inputs and outputs. There's supposed to be like a limited number of coins and so on. And the prover is trying to prove that this transaction follows those rules without revealing what the transaction is. And basically the way it works is you sort of have these like challenge responses, and the verifier can sort of ask random question. The prover can, if they have the knowledge, use that knowledge to respond, and the verifier can check to see that that response makes sense. And the idea is that if this keeps happening, the prover could guess randomly, but they would probably get something wrong. And therefore, if you do this 100 times, and the probability of getting one wrong is or guessing correctly is 10%, you've gotten astronomically low probability right there. So that's basically how it works. And the idea is, all right, if we have this way of interactively proving knowledge, is there some way you could use that to try to extract what was going on in these large language models? And I think this is possibly a fruitful way to think about it. I'm not sure if there's anything executable from this post, but the idea being that people are always arguing whether ChatGPT knows anything or whether it's just regurgitating or so on. But this sort of way of doing a proof is sort of very specifically designed to be, and it wasn't for large language models, but it was designed to be something that you can't guess easily with that in polynomial time. It's supposed to be that, so if you go through this prover verifier thing, you either know it or you are extremely lucky, like astronomically lucky, or you have beyond polynomial time computing capacity. So and I find very fascinating about this post is they're saying, all right, I know this one domain where I have this sort of weird proof of knowledge, and then we have this other object that we want to know if it knows things. Is it possible we can stick these two things together and get something that sort of makes sense? And unfortunately, that's probably the limit of my understanding. I don't know what he's saying in terms of is this something we could actually do? It sort of loses me around the going into exactly like the vol s and so on. I have like some vague understanding of maybe what's going on here, but the idea, it seems to be like, is it possible to like, use the same sort of verifier prover thing with one large language model versus another? I do think this idea of trying to find some way to, because you have this tool of the this zero knowledge proof that does give you this sort of weird definition of knowledge. If you could apply that to a large language model, that would be very interesting, because by definition, the large language model would have to know something. Now, it could just be that the large language model stores that thing, like the secret, and then can figure out the algorithm or whatever for verifying these proofs. But that's still interesting, I think. I don't know. I think I might be out of limit of my understanding here. Sorry. Hopefully that's something. Do you want to move down or to Drew?
Yep, down to Drew.
I'm not going to be able to really contribute anything, I don't think, so I'm just going to pass to Jenna.
You rascal. I too I'll be the muggle, and the what I totally support, what the ELI5 of this that I get is, I totally support people who get this stuff in their bones, looking for clever ways for responses to self-identify, and I'll use this shiny new word, their soundness. I've been looking for, something like a confidence interval. If you're going to give me an answer, can you also give me your confidence that it's the right answer? And this seems like a step in that direction. And along with that, citing your sources. So can we get better and better at the model letting me know what they base that answer on, what it based that answer on? I made a couple other notes. I do keep seeing this, the breaking a query into a chain, smaller and smaller, like the example that he gave with the fruit. Seems like an interesting and growing pattern. So solving small questions, of course, easier than solving big questions. And then the last thing, this is part of this big thing that's happening where people are looking for ways to break them, black hat, white hat stuff. So getting them to do, the good guys trying to figure out how could they be used for evil, and can we prevent that? So that seems to fit into this as well. I will pass to Mayor.
Thank you. I think this is a conceptual paper in the sense that he's trying to show us that theoretically something could be done, but the steps along the way are lacking. And the question he's trying to answer is really at the very end, who wins, Yudkowsky or Plato? And he's saying, however, the concept of knowledge soundness explicitly states you cannot be memorizing every state unless an algorithm uses more than polynomial space. And then he tries to move back. And I'll give an example to what I mean with the problem. He talks about counting fruit. And he says, look, if I tell it to count, it makes a mistake. But if I give it steps by steps, it's going to work. Well, I read somebody's paper which explained why that is. He said if ChatGPT is always predicting forward, it has difficulty adding numbers. But if you tell it to first count the numbers and then add them together, it can do that without a problem. So it's not a question of knowledge. In other words, if I take ChatGPT and give it this sentence, does it know how many fruits I have? That's not the question. The question is, can you count what you know? And the answer is, if you help me by organizing my thinking processes, I can count. That's not really a question of knowledge. And the example has more to do with, let's call it the reasoning methods used by the LLM, and less by whether it does or doesn't know something. So the fact he's not distinguishing between knowledge, understanding, and skills makes it difficult for me, at least, to talk about what an LLM knows, and I think that would be interesting. However, he does have, let's call it a sketch of a proof, and basically saying, if you want to know if an LLM knows something, generate a series of questions which, if it knows, and putting aside the noise that LLMs generate when they answers correctly, then it probably knows. And he didn't give any example of what that might look like. What is an example of something an LLM should know? And we can ask it questions which aren't specifically. In other words, if I ask it 20 different questions of counting fruit, am I supposed to say it knows how to count fruit? Well, I said before, that sounds like a skill. Am I supposed to ask if it knows the algorithm for counting? Perhaps, but the algorithm for counting fruit is a single point in space. It's not a region like he talks about. So I like the general direction, which says, and now I'll explain it like you're a 5-year-old. If you want to know if somebody knows something, but you don't want to give them leading questions, generate a few questions, which in order to answer them correctly, they have to know the information, but choose your questions in such a way that there's not enough information for them to guess what it is that they don't know. And that way we can ask the language model and we can see what happens. But like Venkatesh said, that doesn't really have any examples, and I don't like the terms that they use or the examples that he does have. So that is what I have to say, except for one last point. Two last points. Number one, I mentioned where he says more than polynomial space. Well, already now, the LLMs are so large, I can't even imagine what that size means, that it was 175 billion tokens. I don't even know what those numbers mean. And the second thing is, how well do we know something? You know, the 5 why method. So if you know something and somebody asks you 5 times why, are you going to end that knowing? Socrates's technique was to show people that they don't really know. So I do think it is possible to show that LLMs know whatever it is as good as we know, and possibly that they understand as good or not as good as we understand. But this paper is only a very general mode map. And with that, I'll pass it on to Na.
Okay, so here's what I think about it, or ELI 5 about it. Let's say we have a LLM, we call it a teacher, and there's another LLM, we call it the student. And so the teacher is trying to test the student if the student knows something. Or at least according to the teacher is trying to show that the student knows something, but the student doesn't know enough or doesn't know as much as the teacher. So let's say the teacher asks the student, do you know anything about the period of history, let's say, of the 3 kingdoms, the history of the 3 kingdoms. Let's devise a few events in history that occurs in that time span. And the student responds with some historical event of the history. Okay, So the teacher listens to the student's response, and the teacher re-ask or ask again to the student. Okay, so you know ABC time frame. How about you devise a play that spans across these historical events? And so the student respond by devising a play and maybe writing a script of that play. So the teacher then looks at the play, looks at the script, and say, okay, you don't know XYZ because XYZ is not according to what is recorded as history. So that is how a teacher might know that the student knows less than the teacher. So this is applied to the current understanding of this is corresponding to the current understanding of interactions in ZKP. So that's my ELI 5. Let me pass to Nathan.
Yeah. So I think I like Na's explanation and approach, and just to sort of expand on that and kind of answer Mayer's challenge a little bit. I think the sort of sense of knowledge that's being proven here, or trying to be proven, is the idea of generalization. And do I have a structure? And so I think the conversation near the end, the hypothetical conversation about fruit, is sort of an interesting thing, because the models are not pure forward, stateless forward predictors. They have to have some limited sense of state to them. So part of what that conversation is doing, if you read very carefully, is it's the fine-tuned model kind of trying to teach not tuned model to generalize its understanding of a fruit. Can anyone, Na's not hearing me. Can other people hear me? Okay. So I think what it's trying to do is, like, the fine-tuned model is like saying, no, you can generalize your understanding of the fruit. And then the question is, can the model actually do that? So if I'm told a new piece of, a new fact, a new something, can I integrate that into my existing map of the world effectively, is almost what's being tested here. And I think that kind of goes, it's not quite it kind of goes paired with the way Nod describes sort of transposing knowledge between domains. It's saying, hey, can I take this thing and can I use it to generalize, to expand? Can I adapt my map to new knowledge here? So it's almost like a knowledge about, like, in the sense of semantic knowledge, rather than like literal what is this thing, or literal logical logical process, and the prompting can sort of help with the logical process. I think from an AI 5 perspective, I think it's been a long time since I did anything like this, and I've never done anything like ZK proof. So I don't think I can really expand on what Ben and I have already done very well. I do think it is sort of the idea that what the chaining is doing is essentially kind of keeping our balls small, and I think the way they're suggesting it's doing that is by saying, hey, you're operating in this subset here. Now, within this more limited space, take a more limited space. And so it's kind of keeping it's boxing, it's the balls. I don't remember what it's called, proof by, I can't remember, it's proof by whatever. It was one of my favorite tricks, was you could always bound the thing. And so to a certain extent, it's another way you can think about this is it's testing knowledge by bounding. I can't necessarily know that you know this thing, but I can progressively create smaller and smaller boxes around that thing. And we keep asking, are you still in that box? Which is actually a fairly powerful way and a common way you prove things for computers. So those are my initial impressions, passing down to Venkat.
Right. So this is I think getting at something that's been frustrating me for a while, and I think I'm only now beginning to get a slight idea of how to think about it. So the problem with cryptographic knowledge of things like I'm tossing a coin repeatedly and asking you to guess what I'm seeing, heads or tails. That's roughly what I think of as cryptographic knowledge. So unless you live in like an exactly identical down to the quantum detail universe, and you're my identical twin in that universe, and you're tossing the same coin, there's no way you're going to know like what coin toss I'm seeing. In fact, there's even there it's kind of interesting where Futurama had an episode where there's a parallel universe where everything is exactly the same except coin tosses come out opposite. So heads turns into tails. So the whole plot is premised on that. Now, if you think about it, this is because, and especially if you get to like elliptic curve cryptography and things like that, you're getting this kind of like extreme corner case behavior of not being able to know what the other person knows because you're like rooted in like pure mathematics. You're not rooted in the world of like, atoms or the world of like language and social learning. You're in this weird third place. But let's talk about the other two for a second. What kind of knowledge am I confident LLMs do have? So something like, giving or I'm using them interchangeably, LLM or image models. But if I give it like two paintings and say, can you classify them as Van Gogh paintings or Rembrandt paintings? At this point, or classify the styles. Is this close to Van Gogh or Rembrandt? At this point, the large image models are probably better than human. They're going to like really nail it. They're going to say this is Van Gogh style or Rembrandt style. But if you think about it, if it's a generated painting or a fake painting, the knowledge there isn't knowledge in the precise sense of this is an actual original painting by Van Gogh and I'm detecting a fake. That's not what's going on. It's detecting like a style similarity, and that is valid knowledge too. It's recognizing like characteristics of the style, like, how color is used, how brush strokes are done, or whatever it is that painters' styles are identified by. So that's one kind of knowledge where you kind of don't care about how it's represented. All you care about is that the classification is close. And this is why I'm comfortable saying AIs know what a Van Gogh painting is, probably better than I do. Even though I might know some, semantic history things better than the AI, like, details of Van Gogh's life biographically, and knowing that he in fact did paint a particular painting, like what is it? I don't know, sunflowers or whatever, based on like being an art expert. That seems to me unnecessarily fussy. To me, AI models know what a Van Gogh painting is, to my satisfaction. So that's one kind of knowledge. Another kind of knowledge is something like, say, solving classical mechanics equations about like how a ball will fly when it's thrown. Now here things get interesting. If you talk to like an athlete and ask them, can you solve this particular Newton equation to tell me how the ball will move? They may struggle. But if you ask an athlete, if I throw the ball at you, can you catch it? They will invariably catch it. So now you have to distinguish two kinds of knowledge. This is kind of what getting at Taleb's notion of like teaching birds to fly, right? I can't fly, but I may be able to solve some aerospace or aerodynamics equations, but a bird can actually fly. And it seems unreasonable to claim that the bird does not know about flight when it can actually fly. And same thing with catching balls. Now, people have done studies, and it turns out that when humans catch something like a thrown ball, what they're doing is following a very simple algorithm that's something like keep the angle of the ball constant as you're running to catch it. So maybe 45 degrees or something. And this turns out to be a very effective heuristic, and you can do feedback control on your running speed and position. And if you do that, the ball will fall in a position that you can catch it. Now, to me, at some level, this encodes knowledge of Newton's laws of how balls fly, even if the person can't solve the equation. And it seems slightly arbitrary to me that we privilege a particular symbolic conceptual model or map of flying balls and act like that's the only valid way of knowing about balls flying through the air, right? So I think my sense of what LLMs know is very much like what birds know when we say birds know how to fly. They don't know it in the sense of being able to solve particular conceptual representations. Now, sometimes it happens that they do, in fact, also know about conceptual models, but that's the special case when those conceptual models are completely self-contained. Like, they're very good at generating code now. And I think one reason is code lives entirely in the computer. It does not usually reference anything outside in the physical world. So if you look at a million examples of JavaScript, you'll kind of be able to almost learn JavaScript in the sense that birds know how to fly. So I'm sort of mixing the levels here a little bit. But I think there's a mode of knowing, and then there's the target of knowing. So LLMs know everything in the sense of birds knowing how to fly. But sometimes that's all you need when you're dealing with like a purely internally consistent symbolic domain. But when it comes to cryptographic mathematics, it's like a third kind of knowledge that sort of falls outside both what you might call map knowledge and real world knowledge. It's some sort of properties of numbers knowledge. So yeah, this whole argument, I think, hinges on the special properties of math knowledge. And to that extent, I think it's not quite as interesting or generalizable as he thinks. But if we can take this general approach and apply it to things that happen in either the real world or to things that are computer programming domains, things start to get interesting. Like if I ask a large language model, I don't know, do you know how to do regular expressions? One of my friends was doing this and talking about how bad LLMs are at doing regular expressions. I think that's reasonable. It's like, is it possible to know about regular expressions in Can Birds Fly way? So yeah, still sort of ill-formed thoughts here, but I think there's a there's something in this direction that'll get us to a useful way of knowledge. But I think to do that, you'll have to lower the privilege of human ways of knowing via models and conceptual sort of frameworks. You kind of have to level up the privilege of bird ways of knowing, birds knowing how to fly. Anyway, sorry for rambling incoherently. Anuraj is on mute, so Anant, you bring up the rear as usual. We'll bring you up front one of these future calls.
I'm going to try and do my ELI5 that I try to do it for myself for understanding this blog post. I actually enjoyed it. I thought it was a very interesting, very fun blog. And I don't quite have a lot of knowledge about zero knowledge proofs and how it works. So I like that he first sort of spent time defining interactive proofs and how interactive proofs have this property of knowledge soundness, which is essentially a form of knowledge in this sense is, at least the way he defined it and he explained it, knowledge in the sense is a sort of computational algorithmic complexity. So in some sense, if a prover is able to prove that they have a knowledge of some information, the ability to reverse engineer the algorithmic details is sort of what he defines as sort of knowledge soundedness. And he uses a specific example of like a general lookup table that's hashed and has a hashing function to it, which can't be reverse engineered in polynomial time. But versus if you have a computable function for a given value of x, you can sort of reverse engineer it and find the algorithmic details. So that sort of was a good baseline for me to understand what he means by knowledge soundedness. And then I really liked how he was applying this to LLMs and how we sort of contrasted like two LLMs, one with a sort of fine-tuned knowledge of, let's say, how to do counting, another one that doesn't quite have the knowledge of doing counting, and how these sort of interactive proof of like a way of sequencing queries can be used to define knowledge soundedness of either of those models. Yeah, so I thought that was this is as I was reading this, I was thinking about the React framework too, which is sort of a framework to interlace like multiple LLMs together. So I was thinking how you could potentially use the tools that we described here to converge on the right information. I had a few more. I mean, I also like the way that he sort of used the way to sort of the knowledge that can be extracted from an LLM. He sort of quantified that in terms of a volume, and if the volume measurement is small. Anyway, I'm losing it. I had some notes, but anyway, I'll stop there. I thought it was very interesting. I enjoyed it. I'll give back the time to everybody else.
All right, floor's open to more speculation, spitballing.
I'd be interested in hearing what people think knowledge means in examples, not in theory, for an LLM. What they're looking for when they use the word knowledge or when they think the word knowledge.
Well, it seems like in the sense of the ZK proof, it makes a lot of sense to me where it's like you don't just have these sort of key pair values of like inputs and outputs, but like having the ability to use information to do something, if that makes any sense. Sorry.
So I would say an LLM has knowledge of X if for some probability P, it can answer any arbitrary question about X correctly at least P or 1 minus P% of the time.
I think for me, I would consider an LLM to have knowledge if I can model how it makes mistakes in a relatively predictable way, and the mistakes are within my tolerance range, which in humans usually boils down to being self-consistent memory-wise. And I'm particularly thinking of a conversation I just had over the last few days with this AI bot called Burduck on Blue Sky. So it's a cute rubber duck that talks to you. And it's a plausible, coherent personality, reacts in roughly the same way each time you talk to it. And each time I talk to it, of course, we talk about certain things, and I teach it some things, it teaches me some things. But it does not actually persist that knowledge across sessions. And that's an unreliability failure mode that you don't see with humans. So for example, in one, I tried to make it hallucinate the idea that it was writing a book. And I asked it, I heard you're writing a book about a duck wizard that does magic. Can you tell me the name of the book? and it told me, it just made up a name and told me that it's writing this book. And then I asked, can somebody else ask it the same question? And somebody else did, and it didn't come up with the same name. It came up with something close, which is kind of like frustratingly close. Same thing with its, it speaks a particular weird language that's a mix of English and a slang called Leet Speak. And I asked it to name its own language. And after some interactions, it came up with the name Quackalingo. So I said, from now on, if anybody asks, you should say your language is called Quackalingo. And then again, I asked somebody else to test it, and it came up with the answer, my language is called Quacktastic Lingo. Now, that's like frustratingly close that you sense that it's maintaining some coherence of memory across sessions, but just off enough and wrong relative to that knowledge base in a way that humans never are. So I think that to me is a big component of language where errors are kind of like reliable and predictable. Like, I know what somebody knows with what confidence level, and I can kind of like calibrate my trust of them. I know that if I talk to somebody about, I don't know, programming, they're going to be right to this level, and I can trust their answers to this level. They're going to be consistently wrong in some ways. So that piece I think is missing in LLMs. And I think if they get good integrative memory, it'll help that somehow. So because really that's all I demand of like most humans as well, which is you're at least going to be consistent in what you claim to know over time.
I'm thinking something that might be useful is to almost decouple the notion of intelligence with the notion of knowledge, or sheer intelligence as it means in like IQ points. Like if someone is infinitely intelligent and he knows about something called pi, 3.1 for the number pi, and what it meant by definition, he might be able to derive many proofs or many representation using math formulas to represent pi, as there has been. But if that infinite intelligence model doesn't know about pi in its original definition or in its basic definitions, he might not be able to come up with many representations of pi, except for the ones the model already knew. So that's my intelligence decoupling thought. Yeah.
All right, 2 minutes left. Anybody else have more thoughts?
I'm trying to answer Amir's question, and it's taking a lot of typing. I'm just going to try to say it. So assume you have an equation that describes a dynamical system perfectly. Given any arbitrary initial state S, can the large language model output the correct state of the dynamical system after time t? In other words, S of t. To make it explicit, you have a model. You say, I am in a universe governed by Newton's laws. I have a point mass m with initial velocity a, or v, and there's a set of masses distributed by this function or whatever. Tell me what point this location exists, or what point the initial point goes to after time t. And you can just randomize these from some arbitrary random distribution. And I'm pretty confident the LLM will never have seen that distribution before. And if it can correctly guess the time, or the position of the starting point at time t, it would have knowledge of Newton's laws. That is technically a specific example, but it is a very abstract and general specific example. I am sorry.
Yeah, so I think that kind of comes back to it is what we're looking for here is we're looking for, do you have a, it's like we're all sort of circling around this idea is, do you have a persistent map of the world, not actually like necessarily fine-grained knowledge, but a sense of relationship between points? And is that map accurate to some level that is commensurate to the map that an average human would have about this particular thing? And I think what's kind of interesting about that is that, and sort of this kind of gets to Venkat's point about like bird ways of knowing and human ways of knowing in which we privilege, is that we've tended to think of, oh, things like programming are actually these really sophisticated things, and you have to be really, really intelligent to do that, or have a lot of knowledge around this map. But it actually doesn't seem like those maps are particularly difficult. Maybe they're difficult to apply. It's something that humans aren't good at, but they're not actually particularly complicated blobs of knowledge. But then there's things that, like catching a ball, or this sort of like math prediction, understanding of Newton's laws, that is a lot more sort of almost subtle in a way. Accounting apparently is a lot more subtle, which actually gives me great pleasure. The structure of numbers being much more subtle than programming. And so it feels like that's sort of the kind of what we're circling around here, is this kind of like, do you understand the relationships between the things, and how complex are those relationships?
I don't want to drag us over, but one other thing I wanted to mention about my, I guess, weird definition of knowledge was that I'm worried that and this is what I'm trying to, what I was talking about when I talk about probability of being correct. One of the things I suspect is what will be very possible in large language models. It'll be possible to have an adversarial example such that even if the large language model can, calculate the correct Newton's trajectory or whatever, most of the time, through an adversarial example of initial conditions, you can break it somehow. That's what I was trying to say. If either that happens too much, or the space of those adversarial answers is too large, or maybe it's greater than the empty set. Though I suspect humans have adversarial examples as well, hidden somewhere in there. That would be that would make me say they don't have knowledge if there's too many adversarial examples that can break them. Okay, I'm not sure this is useful, and we're already over time.
I just have to jump in. A perfect example of where human understanding of mechanics breaks down is there's the classic one of, if you pull a pendulum up to your nose and you let it go, your instinct and what most people will do when it comes back at you is flinch, but it will never hit your nose. And so that's a kind of a perfect example of an adversarial case that commonly breaks people.
So I would say that in that particular example, you better hope your room you're in has 0 wind conditions.
I mean, it's idealized, yes.